to figure out pH, what do we need to know? What's the pH equation? pH equals what? We need to know the H plus concentration to do this, right? They gave us the concentration of the whole thing. So what they're doing here is they're saying HNO3, its concentration is 0.10. Now, here's a neat thing. If you have a strong acid or a strong base, you don't need an ice chart. Which means the problems are way quicker and easier if you're dealing with a strong acid or a strong base. Is HNO3 a strong acid or a strong base? Yeah, tough to remember, right? There were 7 of them, the strong acids we had to memorize. This was like the 7th one. This was the last one on there. So it is considered a strong acid, all right? Now if you're like, I don't remember what they are, remember, this chapter is linked with the acid and base chapter and the pH chapter. So make sure that you have those notes available for you. So if something like this pops up, you know that it's a strong acid, all right? The cool thing about this is there's no ice chart needed, which means we don't have to figure out all that stuff. We can actually look at this and say, all right, it's a strong acid. That means there's 1 arrow. So what's this going to break apart into? Well, you guys know because we did this before. It's going to break up into H plus and then NO3. It's just going to dissociate. So that's all we really need to do with this problem is break it apart. Now you're like, well, how does that help us solve this? If you know that this is 0.1 and there's one of these for every one of these, there's one H plus for every HNO3, this is also going to be 1.0 molar, and this is also going to be 0.10 molar. Now you know the H plus concentration because it's this. So now you can plug it into the pH equation. And this only works again if it's a strong acid or a strong base. So we're actually going to just plug in this 0.10 into here, and then we can solve for the pH like we did a couple chapters ago, last chapter. pH equals negative log of 0.10 molar. And that means the pH is going to be, what'd you get, Schultz? Yeah, the pH is going to be 1. Because this is 1 times 10 to the negative first. Which means, remember that little trick we did? If the coefficient's 1, all that stuff is 1, you flip it around. So the pH is going to be 1. Don't forget about sig figs though. It's going to be 1.00 because this has 2 sig figs here. So we're just going to get a pH of 1 for this problem. So even though in this chapter it was all about ice charts and equilibrium and all that stuff, we're still going to be dealing with pH in here also. So if it's a strong acid, that's it. You don't have to do an ice chart. You don't have to do all that extra stuff. You can just solve it kind of like we did a chapter ago. All right?